Hi folks, first I have to give a shout out to RJ for literally setting up my talk in an amazing way, talking about the importance of your data loop, that we're moving more to not just a model-centric view, but to a data-centric view. I mean, the check is in the mail, RJ, trust me. All right, let's figure this out. So today I'm going to talk about the 3 of the pitfalls in ML for ML model failure and what to do about them. Assuming my clicker works. Oh, there we go. Whoop. Me, I think I got introduced. So I lead the product development team at Sama. I'm a CPO there. I've got a lot of expertise in the ADAS and AV field, former head of product at Zoox, former VP of product at Aptiv, also worked at Google. I've been in this industry, much like what RJ said, a fairly long time, and seen a lot of the evolution and changes. I'm really personally interested in the intersection of humans and machines, and I really resonate with what Sama's mission, ethical mission as well there. So I want to start with the premise that even according to data scientists, most of your models, 80% of models, fail to reach production. So that's whether it's within AV or outside of it in the broader sense. That's a really high percentage. And what we're really seeing is that is coming down to those data loops and the problems that we're having with them. So I'm going to talk, as I said, 3 of those pitfalls. Now, the first pitfall that I wanted to talk about was making sure that you strategically annotate your data. So one of the problems is, as RJ said, there was a rebalancing that he put on his slide as well. And that's one part of it, is that not all data is the right data for your model. Is it going to progress your model forward? Is it too similar to the data that I've had before? Is it going to actually serve the use cases and needs that I have? And so what you need to know is what data will have the biggest impact on your model. It's not cost effective. We do data annotation, and I'm telling you, you shouldn't annotate all of your data. You want to annotate the right data that is going to have an impact for you. You really need to track edge cases. Edge cases are really important, as partly what RJ was saying before as well, is that they tell you where your model is not performing or where your instructions for how to annotate the data are ineffective currently. And so you can then clarify, you can calibrate, you can make sure that you can discover new areas where your model's not performing at a very early stage in the cycle, instead of waiting until you're seeing the results of deploying that model and waiting for the results at the end there. And you also want to make sure you have a diverse mix of data to annotate. So you can see here that we've got, in the top right, a cluster analysis where, let's say a new batch of data comes through. We can tell you instantly, hey, this data looks like data that we've annotated before. Or we can show you hey, this is really new for a particular reason. We can look at the embeddings and the cluster analysis and say hey, this is really going to be valuable and something you should consider including certainly within your model. And then down the bottom here, you can see the edge cases that I was talking about before. One of the nice things about working at Sama is that we're the people who see every single piece of your data. So there's too much data for your data scientists and your very expensive, thanks again RJ, give me another one, very expensive ML team to be manually looking through every piece of your data. As we're annotating it, we actually get to see every single piece. That means that we can proactively identify things that are falling outside of the norm, things that are interesting, things that may spark an interest for your ML engineers to go, data spelunking and mining and saying let's do a similarity search. Show me some more content that looks like that. Why is it failing? One of the things we've heard repeatedly from customers is that, great, maybe my model, maybe my PR my precision went down or my recall went down, but figuring out why can be a really, really lengthy process. And so by having a proactive set of communication around this, it can really help you proactively decide, hey, do I need a different set of data? Do I actually need to consider a new object type or a new behavior type that I hadn't been considering in the past? Pitfall number 2 is you can have poor quality or inefficient annotations. So you can also, as RJ had said, man, I'm just going to keep doing a callback. RJ totally set me up here. There can be incorrect labels, but there can also be inefficient labeling. And so what you want to do there is, models are relatively resilient to a small amount of error, but you want to do everything you possibly can to ensure that your data is of the highest quality possible. So what we have is, at Sama we have automated quality assurance, which is where you can use, computational checks to make sure that things are logically valid. You can use ML algorithms to do different ML algorithms to check the answers and flag it for a human. You might say, hey, this algorithm's like 90% sure that the thing you said was a car is actually a bus. And so then you can flag it for a human review that can either tell them, oh yeah, that's absolutely correct, let me fix that. Or it can be like, ooh, actually no, that's wrong. And so you still, at the end of the day, end up with very high quality data. Another thing we get and we see quite often is sensor noise. So not just the raindrops that we were seeing in the last presentation, but you can just get noise in general from raindrops as one example, but in other places where you may just have noisy sensors. We also can see very low quality sensors, as was talked about in one of the Ford presentations earlier today. One of the goals that a lot of these teams have is, how do you reduce cost? So maybe we want to go with a 4 megapixel camera instead of an 8 or a 16. Where do you want to get to? Sometimes that can have a real degradation in the earlier training phases of the speed and the quality of annotation. So here's an example I want to show is that one of the things that we do is that we can actually slam your data together for your LiDAR point cloud so that we can actually end up adjusting the pose of individual frames so that this task here is there's a van. So there's a van that's got LiDAR detections across it. And what you see on the left here is that the pose actually changes across frames. And so that pose, if I was to just try to annotate this vehicle, I would need to start in the first frame, move the box. Maybe I can use some linear interpolation. There's other ways I could handle that. Or once we've actually fixed the pose across every frame, we've got it consistent, then you can see I can drop a single cuboid at the beginning and capture the vast majority of that van on the right there. And so that's an example of where it's not just about sensor noise and quality, but also about the tools that are being used to annotate and what tools we're giving the human annotators to make it as efficient as possible. So also inefficient processes. Who's seen a process where you actually added more to the process and you ended up taking less time in the end? So what you'd need is the right steps in your process. So you can see some examples where we might pre-process the data. So that might be where we fix the calibration. So by actually adding a step, even if it's just a step in your pipeline, you've actually improved the efficiency of your pipeline. It takes less time further down the process to be able to check for it. You may add validation loops or quality checks, additional quality checks. That means that the data that flows out of the end of the pipeline, the first time that it comes back to you as a customer, is a much higher quality, resulting in less rework, in less time you need to spend on fixing labeling errors in your work. So I think that that's a really key takeaway when you're considering, hey, how do I want to make sure that my data is really high quality? It can be cheap, but you may not get the right data the first time. You might spend a lot of time, a lot of rework, and that's a delay to your whole program. It's not just about the cost initially. We think very much more about the total cost of ownership. And what that means is, are you getting it right and delivering it to me the way we've agreed the first time? Really important piece to think about there. Finally, pitfall 3 is a lack of visibility when validating your models. Now, that can also be during the early development stage. It can be later, once you're in production. It could be once you're deployed. An example here I like to give is that imagine that there is 1% incorrect labeled data in your entire data set. But if you're not looking deeper, is that in this example, 4% of errors total in your data set. You can see 3% of the errors come from all other classes, but 1% of the errors here are from motorbikes. And there's only 1 other percent that's actually annotated correctly. That would mean that in this data set where you've hit 96% quality, 4% errors, 50% of them reside within a specific class. How do you think your model is going to perform on motorbikes when you're dealing with data like that? Quite a simple example, but hope you can see where I'm going with that. The next one is getting your model to maturity and the visibility that you need at different stages. So obviously when you're starting out with a POC or a new model that you're trying to create, you've got different criteria and what you're trying to look for. So you might start with a lower data volume. you still need high quality data for your use case, but you may not actually need perfect annotation. At this early stage, what you're trying to do is see, am I directionally correct? But then once you want to go further along to actually production and deployment, that completely flips on its head. You need a very diverse set of data, but you need to have a larger volume, but the quality of annotation needs to be much higher. Going back to, once again, another $20 for RJ, that feedback loop, once you're getting there on the quality of your data, is going to make more of an impact than trying to find the latest, hottest new model that's making performance gains. So, and the visibility that you can have into your data at this stage is super important. Being able to understand how your model's performing, what edge cases are actually, what errors is your model actually having? Are they consistent errors? Are there certain classes that you're actually having problems with? Being able to spelunk into the reasons why your model is having a problem is going to be very, very important as you get through to validating your model. One of the things we like to do is also take model predictions. So it can speed up annotation later on, but what we can also do is then really give feedback to the client on why is the model failing, and giving many more specific examples that we can then use things like similarity search to find similar examples of where your model might be failing, to really speed up your ML development team's time so that they're not just getting scores of how did your model perform, you're getting insights. And finally, you want to build resilience. So an example I like to give is that it's impossible to predict the future. About 7 or 8 years ago, we saw an introduction of a new class of objects. So that is an e-mobility scooter. That didn't used to be common in cities. What was common, if you look across a reasonably large data set, was skateboards. Skateboards actually look pretty similar to that. But I don't know too many skateboards that can travel at 40 to 50 miles per hour and regularly choose to use lanes of the road in the way that we see these kind of e-scooters do frequently in many, many major cities. That was something that, as data is being collected and this wave and trend was starting to happen, is a very easy way to identify, hey, actually, I need to introduce a new object class or a new classification so that we can make sure that we have enough data around it, and we need new behavior. So this isn't just about how it affects data annotation and labeling. This is also about what information are you feeding back to your ML development team. You're like, great, so if I'm on the behavioral planner or prediction team, I've now just been given an insight that I have a new class that I'm going to need to start predicting and building a new model or integrating into an existing model with a new class to say, how should I think about how this is going to perform? A great example that was given earlier was, bicycles can behave pretty erratically when they get on the road. Skateboards, for example, don't behave as erratically when they get on the road, but an e-scooter is much more likely to share the lane with you. So you're going to need to understand that much better. And finally, I'd like to share an exciting announcement. We at Sama have been doing this for a very long time, for 15 years. We're trusted by top 4 global tier 1 and OEMs with annotation and validation workflows. And we've been doing it at scale. And we consistently have been able to deliver over 10 million frames a day, and shapes per day, sorry, at over a 99% customer acceptance rate. I like that number, 99% customer acceptance. That's not the quality. Yeah, sure, we do 99% quality. We do 95, we do 99.6 regularly. That's cool. We can all agree on what quality means there. What 99% customer acceptance rate means is that our customers are happy with the work that we're doing. We partner with people to make sure that we understand their goals and that the work we're delivering to them is exactly what they're looking for. And so I find that to be way more impactful than someone talking about whichever quality score that they're trying to get. Very subjective if you don't have a full quality rubric to discuss. But how do we achieve that? Because this isn't easy. This is something that, as Sama, we're quite unique in that we're very white-gloved, we're a partner, we really work closely with you on calibration, on other elements, but we also have technology behind it. And we really believe that to get to this really high quality and high customer acceptance rate, that you don't just need technology, but you need a combination of technology and humans in the loop. And so here I am to talk about Platform 2.0, which we've just announced today, which is a centralized platform designed to de-risk your ML, failures, get models into production faster, and lower the total cost of ownership. We do this across our annotate and validate products with using these three techniques and products. We use Sama IQ, which is humans plus technology-driven insights. So those examples I gave before of where edge cases may actually be collected up and provided back as a report that might have, we might have gone on to do things like similarity search, looking at, say, the clustering analysis of your data. Those are the things where we've got this technology plus humans to enable your teams to move faster. Sama Assure is where we do quality at scale. I just said 10 million shapes a day with 99% customer acceptance rate. That's quality, that's scale. We do this through technology. We've got, as I mentioned earlier, things like Auto.AI. We've got things where we can use ML detections to detect errors. We've got quality review steps. We've got customer sampling. We've got a new platform to enable that even better. And we do all of this as part of what we offer. And then finally, Sama Hub is the platform that our annotators log into. It's the platform that clients log into to handle reporting, management, project setup, tracking, seeing these insights, and much more. So I know that I am standing between everyone and food, and it's going to be right there in just a minute. Our booth is right beside the food line, so I'm happy to take questions live, but I also don't want to stop anyone from getting some lunch. So thank you very much.
Yeah, we have some time for questions. Yeah, I'm going to ask one.
There's one.
All right, go ahead.
Hey, thanks for the presentation. I'm just wondering if you could maybe emphasize a bit on how you deal with ambiguity or subjectivity in data.
Ooh.
Because I mean, there is no 98% quality in that sense, because a human in the end will maybe check it on customer side. And will then decide, is it a human or not? If it's very ambiguous, one says no, one says yes,
Yeah, so how do you deal with subjectivity? So in the industry, in data annotation in general, so not just in autonomous vehicles, there's lots of techniques to deal with that. There are some that are, say, for example, consensus voting. So if a case gets flagged that says, hey, I'm pretty confident in this, but it's ambiguous, you can then have additional humans actually go annotate it. If they agree, provides more confidence, and you could pass that through. Another technique that we use even within autonomous vehicles is that we then bring it up for clarification. So if an area seems very subjective, we then actually make sure that we go back and actually have a meet as part of our regular check-ins with our clients. We actually say, hey, let's talk about this case. How would you deal with this? And we're not just doing that to get an answer on one task. What we do, because we've been doing this for 15 years, is we take the guidance that you're providing us and we train our humans to think in a similar way to what our clients do. So why did you come to that subjective answer? What would you like and how would you get that? And so what we would then do, so let's take that, was it a human, was it not question. We'd flag that, we'd have a conversation and calibrate on why would we take it this way. We'll then also flag that kind of data over the next few weeks, show you a few more examples and see recalibrate again and make sure, hey, are we in agreement? This is the way we'd like to do it. We also have rigorous training for our workforce. We've got all of our workforce has an average tenure of 2 to 4 years. We've been doing this for a very long time. And what we do is every project has 2 weeks of training at a minimum just before we even start to make sure that our annotators really understand what you're trying to achieve. Not just the specific instructions, the goals behind it, the subjective nature. We look at examples. We have gold tasks where we actually have annotators actually go annotate some things that we've agreed on that are ground truth to see what the results are and to retrain across specific object class types, instruction changes, edge cases. So we do a lot of that proactively.
Cool. I think we should talk later. Thanks.
Perfect. I'll be right beside the food line.
All right, lunchtime, people. Yep. Now we call it today. I think after the morning session, and let's give a round of applause to. Okay. All right.